given triangle PQR, with vertices P0, 0, Q2, 4, and R6, 0. Determine the equation of the perpendicular bisector of PQ. Determine the equation of the perpendicular bisector of PR, and hence, determine the equation of the circle passing through P, Q, and R. The perpendicular bisector of PQ is a straight line that cuts PQ in half, and also cuts PQ at 90 degrees. In other words, PM equals MQ, and MK is perpendicular to PQ. To determine the equation of MK, which is the perpendicular bisector of PQ, we need to know the gradient of the line, MK, and the coordinates of at least one point that lies on the line, MK. Since we were given the coordinates of points P and Q, and we know that M is the midpoint of PQ, we can use the midpoint formula to determine the coordinates of M. The midpoint of PQ, M, therefore has coordinates 1, 2. We now have the coordinates of a point, M, which lies on the line, MK. We also need to know what the gradient of MK is, to determine the equation of MK. We know that MK is perpendicular to PQ, and since we were given the coordinates of P and Q, we first determine the gradient of PQ. The gradient of PQ is 2, which means that the gradient of MK is -1/2. And now that we know the gradient of MK and the coordinates of point M, we can determine the equation of MK, which is given by y equals -1/2x plus 5/2. To determine the equation of the perpendicular bisector of PR, we proceed in a very similar manner. Since PR is a horizontal line, determining the midpoint of PR is simply a matter of subtracting the x-coordinates of R and P and having the result. Thus, the midpoint of PR is the point T3, 0. The perpendicular bisector of PR is therefore a vertical line that passes through point T. The equation of TH is thus x equals 3. Before we continue, it is important to note the following. The point where two medians meet is called the centroid. A median is a bisector of a line. So, in this example, MK is a median of PQ. The point where two altitudes meet is called the orthocenter. An altitude is a line that is perpendicular to another line. So, MK is an altitude of PQ. And the point where two perpendicular bisectors meet is called the circumcenter. The circumcenter is what you need to pay particular attention to in this problem, since we have determined the equation of two perpendicular bisectors of two sides of a triangle. The term circumcenter means that a circle can be drawn through the vertices of a triangle. When a circle passes through the vertices of a triangle, the triangle is said to be circumscribed. The circumcenter is therefore the center of the circle that passes through the vertices of the circumscribed triangle. To determine the equation of a circle, we need to know the coordinates of the center of the circle, as well as the length of the radius of the circle. Since C is the center of the circle passing through P, Q, and R, and C is the point of intersection of the two perpendicular bisectors, MK and TH, to determine the coordinates of C, we simply equate the equation of MK to that of TH. So, substituting x equals 3 into y equals -1/2x plus 5/2 gives us y equal to 1. The coordinates of C, the center of the circle, are therefore 3, 1. A radius of a circle is a straight line drawn from the center of the circle to any point on the circumference of the circle. We have just determined the coordinates of the center of the circle, C, and we know 3 points, P, Q, and R, which lie on the circumference of the circle. We can therefore choose which point on the circumference of the circle to use, since PC, QC, and RC are all radii of the circle. Since P is the origin, it makes life so much easier to use this point to determine the radius of the circle. Of course, it won't make the slightest difference if Q or R are used instead of P. To determine the length of radius PC, use the distance formula. The length of PC, the radius of the circle, is therefore √10. The equation of the circle is therefore given by x minus 3 all squared plus y minus 1 all squared equals 10.